Good morning. So as you may have heard from some district communication, we are going to start counting assignments as graded starting next week. So really make sure you are following the videos and doing the lessons. So today's exit slip, I'm gonna make half the points where the answers come straight from the activities, like what was the answer to this question, or like something that I've said or wrote exactly in the video. And the other half might be like small extensions off that. So you should be getting at least half if you're watching the video. And then the rest of that would just be like, how well did you actually understand how to do it yourself? So be following along and you should get at least half. The other half will come from understanding how to do it yourself. And that'll be a good way to really make you grade yourself. So first you want to look at these. Which one doesn't belong is really a fancy way of saying what makes each graph unique from the other three. So pause it, take a moment to look and see what makes this graph different from this one, or different from all of the other graphs. What makes each one unique? So pause it, and then we will go over what makes each one unique. So for this first part, there's obviously many other different answers you could have gotten, but here's what I came up with. For A, there are 3 parallel lines, and parallel lines will never intersect each other. So notice there's one line here, here, and here. They never cross, and so there is no intersection point. For part B, there's only 2 graphs. There's 2 lines, as opposed to the others all have 3. And there's 1 intersection point between the 2 graphs. So I just said there's only 2 lines. And also the intersection point I noticed is the only one where the intersection point is over in one of my left quadrants, in either quadrant 2 or 3. For part C, for graph C, I said that all 3 lines intersect at the same point. They'll have that same exact intersection point right there. Sorry, just moving the light. And for part D, I said that all 3 lines intersect one another at different points. So there are 3 different intersection points on this graph. So like these 2 lines intersect here, these 2 lines intersect here, and these 2 lines intersect here. So you get kind of like this triangle shape where they like overlap in the middle. All right. So then on to the next part, making signs. So we're going to look more at systems of equations like we talked about last class, where a system of equations was more than one equation. And we're just going to get really easy into this just because I don't think it's a great thing to go super in-depth on right away. It's good to get just a foundation of what are we doing. So we have Haley and Michael are making signs for all the lockers as part of the decorations for the upcoming Spirit Week. Yesterday, Michael made 15 signs and Haley made 5 signs. So I'm just gonna put Michael's information in pink and Haley's in black. Today they need to make more signs. Each person's progress is shown in the coordinate plane. So first of all, let's see if we can figure out which graph represents Michael and which graph represents Haley. So just take a minute and look at what we already know, and so you can figure out which graph should I color black and which graph should I color pink. Based on the information we're given that Michael made 15 signs yesterday, we guess that this graph up here should be Michael's graph because it starts as a y-intercept of 15, and the graph below has a y-intercept of 5, so that should be Haley's graph. All right. So we want to figure out which statements are true and which ones are false for each person based on the graph. So at 40 minutes, I have 25 signs completed. Was that true for her? Was it true for him? It might be neither, and it might be both. All right, let's give that a try too. So we notice here that at 40 minutes, I have 25 signs completed. Well, point A, let's see, 40 minutes, 25 signs completed. That's actually on both people's graphs. That's on Michael and on Haley's graph. So it's actually true for both of them. Point B, at 75 minutes, I have 42.5 signs completed. That's only on Haley's graph. It's not on Michael's. So she is the only one who gets a check mark there. Michael, after 75 minutes, seems to only have 34-ish signs completed, maybe 33.5, 34. And then for point C, at 0 minutes, well, remember from the problem, Michael had 15 signs made and Haley only had 5. So at 15 minutes, he was there, and she was down there. And at 100 minutes, I have 60 signs completed. That's true for neither of them. Now notice, they had more than 60 signs completed. right, it's not to say like they had at least 60, they had exactly 60. That's what that would mean. So, the points that are on the line refer to true statements about these people. And the point of intersection, as you remember, point A, that's our break-even point. So point A is where both kids have worked the same number of minutes and made the same number of signs. So one of the really important things about this is interpreting that point right there. That's our solution point. That's like that's what we care about, is that intersection. So that point tells us that at 40 minutes, both kids had 25 signs completed. And that point sort of tells us the boundary of like what's happening. Because if we look left of that point, if we have less than 40 minutes or before 40 minutes, who had more signs made? From the graph, it is quite clear that before 40 minutes, Michael had more signs made. Because before 40 minutes, his graph is higher up. The pink graph is higher. But after 40 minutes, sorry, it's hard to write on paper that's not pinned down. After 40 minutes, if I look after that 40-minute mark, Michael has now made less signs than Haley. So after 40 minutes, Haley's made more signs. So what's that? It's called that break-even point. It's the point where Michael went from being more productive to being less productive. All right, and if we recall the example from yesterday, let me see if I can just find it real quick. That bed and breakfast example we talked about yesterday, remember? In the context of that bed and breakfast, the break-even point was the point where they went from, all right, this room has cost us more than we've earned. The revenue was low and the cost was high. But after the break-even point, after that point, they're now earning more than this room has cost them. They're now making a profit. So you remember that from last lesson. So it's just good to refer back to that stuff. It's all the same type of deal we're dealing with. And it's really important to think about the realistic context of these problems, not to get lost in the math. It's important just to realize what this point tells us. All right. So I'll zoom back out so you can see what I have. All right. So let's continue on the back. A pocket full of change. Not sunshine today. It's very gloomy outside today. Jennifer told Tyler that she has $2 worth of quarters and dimes in her pocket and 17 coins altogether. So we're going to get started thinking about two different criteria that's being met. So she says, I have $2 worth of quarters and dimes, which basically means that she has some combination of quarters and dimes that adds to $2. I know the wording here sometimes confuses kids at first. So some combination of quarters and dimes that makes $2. Sorry. So we're going to think about this in the table. So basically, one way to have $2 is to have no quarters. And if I have no quarters, that's $0. Because a quarter is worth 25 cents. And a dime is worth 10 cents. So if I have no quarters, that means I have no dollars in quarters. And if I have no quarters and 20 dimes, 20 times 10 cents, I have 20 dimes, you better believe that's going to be $2. So that combination works. So now, if I had 4 quarters, how much is that? Well, 4 quarters, I hope you all know, is $1. Because 4 times 0.25 is $1. So now I need to have $1 in dimes to make up $2 total. So how many dimes is $1 of dimes? How many dimes makes the remaining $1? And hopefully you figure out the math before I've already done this. I remember last year I had students have a lot of trouble conceptualizing, like, some amount of the $2 is made up of quarters and some amount is made up of dimes. They're trying to figure out, like, all right, 4 quarters is $1. And how many dimes is that? No, it's not how much is it equivalent. It's like I have four quarters that makes $1. I still have to have a total of $2. So I need $1 in dimes. And $1 in dimes is, in fact, 10 dimes. All right? So try to fill out the rest of that table on your own, and we'll go over the answers at the end. So hopefully the mental math isn't too bad or too taxing, but it is important to have some processes in place in case you're struggling to figure out how many quarters or dimes you'd need. So for the second one, we talked about, well, 4 quarters was $1, but how would I figure that out if I didn't know? So I could do $1 divided by, how much is a dime worth? Oh, divide it into groups of dimes, so divide it by 0.1 and I'd get 10. So that's the math I could do. And over here, I know 0 dimes is $0, so I need $2 in quarters. So I could do that $2 divided by how much a quarter is worth. I could do $2 divided by 25 cents, and that would actually give me 8 quarters. So again, you could do that division to help you if you're not so confident with the money counting. So again, down here, 5 dimes, 5 times 0.1 is 50 cents. And let's see. Oh yeah, so $1.50 divided into groups of quarters. Well, divided by 0.25, that'll get me 6 quarters. All right, so I'm gonna make our own. And I'm gonna show you what might happen at the bottom when you try to make your own, so don't get confused. So let's just say, and I'm using a erasable pen here, which is fine, but you might not appreciate it. So let's just say I pick 3 dimes. What if I have 3 dimes? How many quarters can I have? Well, 3 dimes is 30 cents. So that means I now need $1.70 in quarters to make up $2. And some of you might be ahead of me. If I divide that in number of quarters, if I do that division, oh, I got this in my head now. My calculators aren't available. I should get something 6.8, I'm pretty sure. I'm gonna get 6.8 if I do that. I'm like pretty sure I get 6.8. Let me check my math real quick. Yeah, that worked. Sorry. Okay, so yes, I would get 6.8 quarters. And you might be wondering, well, what's wrong with that? And hopefully you're not wondering that. Hopefully you're thinking, you can't have 6.8 quarters, Mr. Roboto. What are you thinking? And that's absolutely right. So that point, while it technically meets the constraint, I could put that in my graph, it does not make sense in context. So that one does not make sense in context. So let's think about one more. I'm actually not going to erase that because it doesn't make sense, but it's good for you to see that it does not make sense. And that might be a question on the homework. Why didn't we stick with 6.8? Why was that bad? Well, you can't have 6.8 quarters. They were trying to cut a quarter into, well, quarters. Still doesn't work. So, let's see. Well, let me show you something. So we had 20 dimes, we had 10 dimes, 0 dimes, and 5 dimes. What do you know about all those numbers? Well, while you think about that, we'll talk about quarters. We had 0 quarters, 4 quarters, 8 quarters, and 6 quarters. So the number of dimes, they were all multiples of 5. So they were all multiples of 5. That might be significant. And the quarters were all an even number of quarters. I'll talk about each one of those as significant. So basically, the quarters, if you have 1 quarter, it's worth 25 cents, right? And no matter how many dimes you add to that, you're never going to get rid of that extra 5 cents. You'll never quite meet the full dollar if you have an odd number of quarters. 25 cents, 75 cents. Whereas if I have 2 quarters, I get 50 cents, and that I can bring up to the next dollar. And if I have a number of dimes that's not a multiple of 5, well, that one's a little harder to see, but if I have like 2 dimes get me to 20 cents. And no matter how many quarters I add to that, I'm only going to get 20 cents. I might get 45 cents or 70 cents or 95 cents, but I'll never end on the full dollar. So basically we need a number of dimes, the multiple of 5, or a number of quarters that's even. So let's think. Quarters. I got 0 quarters, 4, 8, and 6. Let's try 2 quarters. Let's see if I have 2 quarters. That's worth 50 cents. So now I need $1.50 in dimes. So divide that by 0.1, and I would get 15 dimes. Oh, jeez. Okay. So we are now going to throw all of that. Let's think. Okay, we're now going to... Here's a table that shows some combinations of quarters and dimes that are worth $2. Complete the table. We did that. Awesome. Plot these points on the graph, and we're going to do it in pink because that's what I did. But use a different color or different shape because the graph already has something else on it, and we'll see what that is in a minute. So let's see, I'm going to plot 0 quarters and 20 dimes. Okay, quarters is my x-axis, or my q-axis, you could say. Just kidding. Okay, 0 quarters, 20 dimes. 4 quarters and 10 dimes. Okay, so 4 quarters and 10 dimes. 8 quarters and no dimes. Nope, we're down there already. What kind of shape is this graph making? 6 quarters and 5 dimes. What shape is this? Don't say triangle. It kind of is a triangle, you're right. If you look like this, it's a triangle. But if we look, this actually is a straight line. And if I wanted to, I could calculate slope, but I'm not going to do that to you because it's you don't feel like it. Maybe later. I should use a ruler though, but I'm probably not going to. Oh wait, let's do our other point, our last point. 2 quarters and 15 dimes. So let's think 2 quarters and 15 dimes. Oh, it's that point. That might come in handy later. Look at that. So now I got 2 quarters and 15 dimes, and perfect. Everything connects. Okay, I really shouldn't have connected those dots, but that's okay. It's good to show that it's a line. I could also connect these dots. And while we're at it, why not? Let's just connect them. And really I shouldn't connect these dots because I shouldn't be considering what happens if I have like 0.5 quarters or like 1.5 dimes, because I'm not going to do that. Okay. So yeah, try to answer the rest of the 4 questions on your own. Now that we have everything in front of us, let's read number 2. So the graph is the relationship between the number of quarters and the number of dimes when there's a total of 17 coins. So if you remember way back up here, Jennifer told Tyler she had $2 worth of quarters and dimes, and we talked about that a lot. But she also had 17 coins all together. That's the graph. So we want to make sure, so the graph, the black graph shows 17 coins all together, right? So like this point here, she could have had 16 quarters, 1 dime. And that's 17 total coins. And like point A goes there, and that's one of the questions you have to answer, which is based very much on that. And then like here, okay, so here, she had, this combination is 4 quarters and 11 dimes. Wait, I'm sorry, not 11 dimes, 13. I know somebody would have corrected me in every class if I'd said that in class. 4 quarters and 13 dimes, because I'm between 12 and 14. And again, that's a total of 17 quarters, and that's how I knew I was wrong, because I knew it had to be a combination of 17 quarters. So, what does point A represent? What did that point that we sort of skated right over represent? That's point A right there. I know I scribbled all over it, so you can't even see now. It's point A. How much money in dollars is the combination represented by point A worth? So how much money is that worth? Is it possible for her to have 4 quarters and 13 dimes in her pocket? Like, does that meet our criteria? And how many quarters and dimes must Jennifer have? There is a certain answer to this little riddle she gave him, that she has $2 worth and a total of 17 coins. So you can figure that out from the graph. So pause the video before it cubes on to the next one, and we will have the answers there. So here we are with our solutions. For question 2, part A, what does point A represent? So point A, remember, representing the realistic context. Why do we actually have all these numbers and graphs? Point A represents her having 8 quarters and 9 dimes. So it's that combination of coins. Well, maybe the combination's 8 quarters and 9 dimes, because that adds up to 17 coins. That's why it's in the graph. How much money in dollars is the combination represented by point A worth? Well, 8 quarters is $2, because 8 times 0.25 is $2. And 9 dimes is 90 cents, because 9 times 0.1 is 90 cents. So in total, she has $2.90. So, is it possible for her to have that? Is that her winning combination? No, it does not add $2. Is it possible for Jennifer to have 4 quarters and 13 dimes in her pocket? No, because that totals $2.30, not $2, because 4 quarters is $1, and 13 dimes is $1.30. Too much. So how many quarters and dimes must Jennifer have? Well, she must have 2 quarters and 15 dimes, and again, it's that intersection point. It's the point that's on both of those lines. It's the combination that works for both situations, and we'll see here. 2 quarters is 50 cents. 15 dimes is $1.50, and that adds to $2, so that works. And 2 plus 15 is a total of 17 coins. So that many quarters and dimes gets her $2 and gives her 17 coins. All right, so you'll have some questions based on that. And we're gonna start going over the practice problems really quick. We'll just do a little bit of work for each one, and also how you finish up. So get the practice problem sheet in front of you so we can work on that as well. This video is a bit longer than what you're used to, and here's why. We no longer have a daily exit slip, but I'm gonna have you do more an assignment that's gonna be a little bit longer, but you'll have a little bit more time to do it. So hopefully this will benefit you, and hopefully it'll help give me more feedback. We're just trying this now because in the future we don't necessarily have to have a daily assignment. If you submit it the first day, so like it's Tuesday for all of you now, if you submit it today, like cool. But I think the due date will technically be 1 or 2 more days out. You'll still get stuff posted each day. You might get another assignment next class. It'll probably be a little bit shorter though. But just keep in mind, like, this might not be due right now. So, match the lines M and N to the statements they represent. So I'm gonna go ahead and get started again. I'm gonna just let M be pink because all this black and white is boring. So M is actually this line right here. And I'm just gonna go ahead and draw that whole line to be pink. Just because it should be. I mean, really. So now, and N is the black line. And I'm not going to recolor it over black because it's already black. It's pretty dark black too. So which line represents a set of points where the x and y value of the coordinates of each point have a sum of 2? M or N. So we want to look at the actual ordered pairs in these lines. So basically what that means is if I have an xy on the line, does x plus y give me 2? So let's just pick an ordered pair at each line and test. Let's just go with, I don't know, let's go with point A. Why not? So point A, the ordered pair for point A, the x value, and remember I write this big letters up here. X comes first, y comes second. X is the left and right. How far left and right is it from the origin? And y, how far up and down is it from the origin? Start at the origin. How do I get to point A? Well, I go left 2, that's -2, and up 4. So it's -2, 4. If I do -2 plus 4, does that equal 2? Why, by golly, it does. So it looks to me like it's going to be line N. And let's just double check some other points. Let's just pick, oh geez, oh my goodness, draw my pink pen. Well, that's what happens when you're on live TV, I guess. Let's use purple instead. Purple's pretty close to pink, and I'm not moving the desk. So let's make it purple. Oh dear. And see, you thought you'd get a break from Mr. Roboto's wild antics teaching. Nope, still here. Let's try line M, and hopefully I don't throw this pen across the room. So, let's just try point E. So point E is ordered pair. Let's see, here's my origin. Point E is over, oh goodness, that's 10. These are each 1, so 10, 11, 12, 13 is my X. And then it's up 1, 2, 3, so 13 comma 3. And I don't know about you, but I can tell in my head that 13 plus 3 does not give me 2. So it's not the purple line, so it's gotta be the black line N. So let's try the same 2 points in here. Which line represents the set of points where the y coordinates of each point is 10 less than its x coordinates? So let's look at our 2 points. We had -2 and 4. Is the y 10 less than the x? Is 4 10 less than -2? No. What about 13 and 3? Is 3 10 less than 13? Yes. Okay. And I'm doing this one for you because really, in what universe are we talking about lines like this? I mean, really, there will be realistic context here in all useful problems. So, get that out of the way. So now try to figure out which labeled points on the graph satisfy each statement. All right? So I'm going to pause it here. I'll show the answers quick, and I'll get you started on the back. All right? So I wrote all the coordinates on the graph to help you. I got labeled A, B, C, D, and E. A, B, and C all sum to 2 if you add the x and y values. B, D, and E, the y value is 10 less than the x. I get x minus 10 gives me y. And the only one where it's true for both is B. All right, so try the back real quick. We'll get started on the back. This one's actually an application. And we got some of our familiar faces in here. So Alina earns $7 every day she feeds her neighbor's pet tarantula. That's disgusting. She also earned $14 when she took her other neighbor's pet iguana for a walk. And Brooke earned $30 walking the neighbor's pig and earns $3 per day feeding their cats. So we want to figure out, after they've worked a certain number of days, how much money do they each have. We're going to create a graph of it. And just for the record, if you haven't printed it, it's okay. Your exit step will have a multiple choice graph to choose from. So I wouldn't worry tons if you can't make the graph by paper, but you should be able to think about what the graph's going to look like. So let's just go ahead. She earned $14 when she took the neighbor's pet iguana for a walk. So that's actually our starting value. So to model it with an equation, I would get, for Alina, she'll be purple, I guess. Alina's going to be purple. I'd get y equals 14, and then it's $7 per day. So then after day 1, she got 21, and go ahead and fill the rest in. Brooke is going to be in black. It's a nice alliteration. $30 walking the neighbor's pig, so she started out making $30, and then she earned $3 per day feeding their cats, and hopefully hiding from that pig. Pigs are heavy and scary. Props to you for walking a pig. Okay, so eventually we're going to figure out if each girl works for some number of days, they will have earned the same amount of money, and how much money will each of them have earned. All right. Explain where the solution can be seen in the table. So where do you see that in the table? Just in a sentence say. Don't just write, here it is. You can try that to start, but also think about where do people have to look. If you're directing someone to the solution, where should they look? And create a graph. I'm going to scale the graph for you, just because I know what the graph's going to look like. Let's see, I'm going to count. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, it goes up 16. I'm actually going to count by 4s on my y-axis. You probably don't like that very much, but that's nice. So I'll do 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64. I hope that fits everything. It might fit everything. Yeah, I think it will. Okay, cool. So there's my graph. And I'm going to keep it color-coded. I'm going to do all Alina's points in purple and Brooke's points in black. So pause it, give it a try, and we'll check back. So I finished my table. I graphed Alina's 14 plus 7x, And then I also graphed Brooks, y equals 30 plus $3 per day, 3x. I filled out my table, and I actually already circled number 4, because if each girl works for 4 days, they'll have earned $42. And you get that by looking at the table and saying, which day do they have the same amount of money? So not the same, not the same, not the same, not the same, same, not the same, not the same. So I can create my graph. Again, Alina's graph was purple, started at 14, and I had to approximate, but I had to figure out like where in the gaps it would go. So 14, 21, 28, 35, 42. And Brooks, 30, 33, 36, 39, 42. So we got that. All right. So following along should get you at least half the inch of the exit slip. And then hopefully you can get a few more as well. So, like I said, this won't necessarily be due today. I'll say this is due next C day, but keep in mind, you will get another form or another something to fill out for your next math class. So you'll still have the same number of assignments probably, unless there's a really long one, but I'm gonna extend the due dates out a bit if you need more time to work on it, all right? But you should get it done today.